Hi, I am here demonstrating the process of image encryption and decryption. Uh, I am here using the technology elliptical curve cryptography for this image encryption and decryption process. Then first we will discuss about the basic of this elliptical curve cryptography. This one is the ECC equation. This is a cubic equation, and in this equation we have to find out the coordinates, the values of x and y, with satisfying these equations. And these are our the ECC plot points, and then we will plot the graph of these points, and this graph will look like this. There are three important property of this graph. One of them is the addition. If we have the 2 points like this P1 and P2, if we add these 2 points, then we will got a third point which is also on this curve, and this is the property of addition. Similarly, there is a property of multiplication. If we multiply any point on the curve like P1 by any integer value, then we will got a point, and this point is also on the ECC curve. This is the property of multiplication. The multiplication is the simple multiple addition. Suppose we are multiplying this point P1 by 5, it means we are adding this point 5 times. This is the property of multiplication, multiple addition. There is one more property, that is subtraction. If we are subtracting 2 points P1 and P2, if we are subtracting 2 points P1 and P2, then we will got a point, and this point is also on this curve. These are the property of this ECC curve, which are the important property, and these property are used for image encryption and decryption process. So to find out the points for this curve, we should have the knowledge of the constant a and constant b, and these constant must satisfy this condition. And using these two equations, we can find out the points of this ECC curve. Then we can use this curve for image encryption and decryption process. Here I have plotted a curve. This one is the similar graph. This is a ECC graph, and these green dots are representing the points, the coordinates, the values of x and y coordinates of this graph. And this graph is plotted using these two equations, this one and this equation. Using these two equations, I have generated the points, and using this point I plotted this graph, and I also perform the test of multiplication and addition here over this graph. I selected a point, this point red dot, and then multiply this point by an integer value, then we will got a point, this yellow point and this blue point, and these 2 points are also over this graph, This is a property of our ECC curve. Now this is used for image encryption and decryption process. And how I use this process, this ECC for image encryption decryption, this can be best explained using a table, that is our mapping table. These are the points all which I have generated using two equations of ECC equations. I have generated around 1,23,000 points for image encryption decryption. all these points, and these points are then arranged in such a manner that we can map the pixel intensity of an image easily. And this new arranged matrix is called mapping table. This one is our mapping table, the rearranged form of all points. This is our mapping table. In this mapping table, this first row is our intensity row, means this row is representing the intensities of the image pixels. The three representing that, this row, complete row, the points like this point, the 5, and this is x coordinate and this is the y coordinate. This are the point, this is the point, and this point is corresponding to the intensity 3, and this point is on the ECC curve. Next, this point is also corresponding to the intensity 3, and this point is also on the ECC curve. So for intensity 3 we have total 482 points. We have total 482 points. It means we can map the intensity 482 times. Here the total points are 482. For one point we are using 2 columns, that's why we have the 482 mapping. So for one intensity can be mapped 482 times. And if any intensity value, any pixel value is repeating more than 482 points, then we will start again from the first point, this point 5, and this y coordinate value, and repeat in the same manner. This is our mapping table. Now we will start how the encryption process takes place. This is our main program. Here I am using a image, and I am converting this image from RGB to grayscale image, and after that the encryption process start here. In this process, in the command window, I have to enter a random key. I am entering here a random key 1 2 3. Then it will ask for a private key. I am using a private key 2 3 4, and after that the encryption process start. Now here each pixels are encrypted one by one, and there is a mapping for each pixel one by one. It will take some time. Meanwhile, I am describing here what are the purpose of this random key and the private key. Till now we have generated the points, all possible points over this ECC curve, and after that I have selected a base point, that is G point. This is our base point. Then I am using the two integer value x and y. X and y are the values, integer value that are defined by the sender and the receiver. These are their secret values, and using these secret values and the base points, we can generate the public key. We are multiplying this base point by this integer value, and then we got a public key of A and the public key of B, sender and receiver. Then using this public key, we are also describing here the random integer, and if you multiply this public key of the receiver, public key of receiver is multiplied by this integer value, then we will got the encryption key, and then this encryption key is used for the process of encryption. Here PM is the points, this is the message that we have to encrypt. PM means the point corresponding to the particular intensity value from the mapping table. Suppose the first intensity value in the mapping table is 161, Then we will find out the point corresponding to this intensity value 161 from the mapping table, and these points are the PM, and we will add the encryption key with this point PM, and the resultant output will be our encrypted message, and then we will transmit this encrypted message. This is our encrypted image which we got through the encryption process, and this encrypted image is transmitted at the receiver end, and then receiver will decrypt the message. Then we will start the decryption process. Here for the decryption process, we have to enter the key, random key, that we have used at the encryption process. This is 1 2 3. Then again it will ask for a private key, that is 2 3 4. If I am using here the different key other than these 1 2 3 and 2 3 4, then the decryption process will not be successful and the output will be different image. So if we use the same key, then we will go to the exact output, and if I am using the different key, a single integer different will result in a different image. So I am using here the same image, and the decryption process start here, and it's also take time because the process is 1-to-1 mapping for each pixel. Then how this process take place, I'm just explaining here. The suppose the first point is this 161, the pixel intensity in the image. Then we will find out the mapping table the same intensity and the corresponding point in this mapping table. This one is our intensity 161, and the corresponding point to this intensity is 167, and this value y coordinate value. So when this intensity value comes first time, then we will use these 2 points, and if this value is repeating second time, then we will use this point, and the third time we will use these point, and the process continue so on. And when this intensity value is repeating more than 482 times, then we will start from the first point again, and using this process, through this process we will map each pixel value one by one, and we will use these corresponding point, and we add the encryption key corresponding to these point. After decryption, we will got the image, and this one is the same image which we have used at the time of encryption. So here we are using the same key at the receiver and the sender end, and we are successfully completed the process of encryption and decryption. So in this process we are using this mapping table. First we are the first point, first pixel value is 161, and this pixel value is from the mapping table is mapped here, and the corresponding point is picked from this mapping table, and these corresponding points are these point, and these corresponding point are used, and the encryption key is added with this point, and then we got the new point, and this new point is come here in our encryption message. This this is our new point. This new point is the resultant of the corresponding point to the intensity 161 and the encryption key. And then again the second is our next pixel intensity is 161, and the corresponding, we will find out the corresponding point from the mapping table. This intensity is repeating here second time, that's why we are using these points, and we will add the encryption key here, and then we got the resultant point, this 00, and this process continue, and we map one by one each pixel, and then we got the encrypted message. And this encrypted message, this one is our encrypted message, and this encrypted message is transmitted from transmitter to receiver end, and then receiver receive this message, and then use the same keys for generating the key, for generating the decryption key, and then this decryption key is subtracted one by one from these points. We receive we pick 2 point one by one, this point, then this point, then this point, and subtract this point one by one, then we got the original point of the mapping table. These are the original point corresponding to these intensity value, and we map this intensity value at the transmitting end. This is the complete process of encryption and decryption which we have used here. Thanks.